Hey guys, welcome to my channel. So today we're gonna look at binary search. So it needs no introduction at all. It's one of the most implemented algorithms out there, if not the most. So it utilizes divide and conquer mechanism to quickly find us the element that we're searching for in a group of elements, right? It can be a linked list, can be an array of integers, can be anything. And the only constraint is that it should be sorted, right? So we're gonna learn how to implement and code it up, but we're also gonna learn how it kind of works under the hood. But we're not gonna dive deep into it. It's pretty basic anyway. We don't need a deep dive, but we're gonna go to the whiteboard and see how it works, right? So let's go to the whiteboard now. So what we have, as you can see, we have a group of elements. It's a group of integers, and 1 to 7. So let's say we want to find something out of these group of elements, right? We want to find 2. So our key is 2. Sorry for the handwriting. Now, this is our key, and we gotta find this. So what we do is we take a midpoint. So whenever we start doing binary search, we have an integer declared, which is the midpoint, and how we calculate that. So let's say this is our starting index, and this is our ending index, which is 6. Now we're gonna calculate the mid by adding these two, the starting index and the ending index, and we're gonna divide it by 2. Right? So it's gonna be equal to 3. So our third element is 4 right here. So we're gonna start our binary search from 4 itself, right? We're gonna start from here. Now we're gonna check. Now we're gonna check if the element that we're trying to find is lesser than the mid element or greater than it. Right, so in this case, it's lesser than the mid element. So 2 is lesser than 4. So what we do is, so we decrease our higher index, which is set to 6 right now, and we decrease it to 1 minus the mid element. So 1 minus 3, which is going to be 2, and 2 at 2 index is setting 3. So we're gonna set our higher index to this now, right? So it's eliminated half of the array already, just in like one step. So that's why it's log n amount of time. So it decreases the group of elements that we're searching logarithmically or exponentially, right? So now we have these 3 elements to check with. Now we're going to calculate our mid again. So it's going to be, now it's going to be 0 again. So our lower index hasn't changed. So 0 plus, then this is 2 right now. So this is the second index. So 0 plus 2 divided by 2, which is going to give us 1. Now, in the first index is sitting 2 itself, so we got it already. So we're going to check for a condition. Before we do any of this, we're going to check if the mid element that we're choosing is in itself the key element or not. If it is, then we're just going to return it. And by the way, in case we couldn't find our element in this array, we're going to return -1. So it's if we cannot find it. So we're going to see the code now, and you're going to realize how it works, and we're gonna understand it deeply. So let's do this. Array. Let's have the same elements, 6, 7, and let's code up the binary search function. So static int is gonna return the index, obviously, so it's gonna be int. Let's call it binary search, and it's gonna take a few arguments. Array int key is gonna take the key, obviously, and we're going to also do the lower index, and we're going to also have the higher index, right? Int I. So we need these four arguments for our binary search to work. So there are 2 ways to code binary search, the recursive way and the iterative way. So right now we're going to look at the recursive way, and then after this we'll actually dive into the iterative way, which is pretty simple. It's not much different from this way, but it's actually simpler than this way. So first of all, we're gonna have a base case. So we're gonna check if low is actually lesser or equal to than the high index. If yes, then only we're gonna perform these stuff. If not, then we know that we haven't found the element, so we're going to return -1. So that's how we know that we haven't found the element. So in case the lower index becomes higher than the higher index, then basically we haven't found it because we went through the whole array, right? So pretty simple. Then we're gonna calculate the mid. So int mid equals to low, so low plus high divided by 2, right? And by the way, this is not the best way to do it. We might, if we're dealing with huge numbers or like a lot of elements and the indexes are huge, so it might incur int overflow. I'm gonna leave an article below the description for you to check it out, like to understand int overflow in this case. But we're gonna apply this formula. It's gonna be low plus high minus low divided by 2. This is gonna give us the same low plus high divided by 2 answer anyway. You can check out that article to understand it deeply. So we're gonna focus on binary search and on this. And now we're gonna check. So if array.mid is actually the key, then we're just gonna return mid. So mid is gonna be the index. So we don't need to do anything else. And if it's not, then we can check for two conditions, right? If the array.mid that we are is like greater than the key or it's less than the key. So if array.mid is greater than the key, then we know we have to search for the lower parts of the index, right? So we've gone a little higher. We're gonna have to search for the right, we're gonna have to search for the right part of the array, which has the lower elements or smaller elements, right? So what we're gonna do is for that, we're gonna just return, so we're calling it recursively. Let's call it binary, not binary search, because I don't want to type that much. It's gonna make it clunky. So let's do binary, and we're gonna pass on the array. It's gonna stay the same, key is gonna stay the same, low is also gonna stay the same, but the higher index is gonna change to mid -1. So let's go back to the array. And let's see why that happens. So let's say we're finding 2. Let's say we ended up at 4 because after like first calculation, right? Now 4 is greater than 2. So what we're gonna do is we're gonna search for these elements, so the smaller elements. Now we're gonna disregard these elements. So we're gonna like kind of change the higher index to mid -1. So mid was this, which is the third index, which is the third element. Counting from 0 is the third element. It's actually the fourth element, but whatever. And we're going to set it to 3. So we're just going to be the second index, right? Which is mid -1. So now we're going to search between these items. It's pretty simple, pretty clear. So we're going to do that. And if this doesn't happen, so we have only one case, and in that case where the mid is actually lower than the key element, in that case we're going to decrease or like increase the lower index. So we're not going to do anything for the higher index because we know we have to find in the higher part of the array, right? In the part of the array where elements are actually larger. So we're going to change the lower index. So we're going to return binary array again, key again, and we're going to change the lower index to mid +1, and it's going to be high. Pretty straightforward. Now, if we call this function right now, it actually should work. So let's do binary. Actually, we'll just print it out because we gotta print it out. So binary, let's pass on array, this array, and let's search for 2. The lower index is gonna be 0, and the higher index is gonna be array.length -1. And let's see if it gives us the right index or not. And it did, so it has returned us 1, which is the right index for 2. And let's search for, let's say 5. Let's run it. And see, 5 is at the 4th index, and it has returned us 4. And let's try to find something that doesn't exist in this array, which is 15. It doesn't exist in this array, and we're gonna run it. It will return us -1, as you can see. So yeah, pretty straightforward. Now next we're gonna see how to do it iteratively, right? So we're gonna have a while loop and we're gonna do the same little things. Not much different. It's not gonna be different. So now we're not gonna pass on the higher index and lower index because we're just gonna calculate it inside of the function itself. So let's calculate it. High int low will be 0, and high will be set to array.length minus 1, just declared it inside. So while low is lesser or equals to the high index, same why we're doing this, and we're going to calculate the mid inside, and mid equals to low plus high minus low. And I explained to you why we're doing this. You can always check out the article. So we're gonna check if the element is in itself, the mid element in itself is the key element or not. So if array.mid is actually the key element, then just return mid, right? I can spell return. And then if not, then we're gonna check. So if array.mid is greater than key element, so we're gonna decrease the higher index, right? So let's do it. So we're gonna set the higher index to mid minus 1. Else it's not, then we're gonna set the lower index to mid plus 1. So the same thing, right? So if the element is actually higher than the key element, it's larger, then we're going to check for the right part of the array. So for that to happen, we're going to disregard the half of the array and we're going to set it to mid minus 1. So again, same case. And then if it's not, if it's the other case, which is going to be like if it's lower than the element, then we're going to increase our lower index. We're going to set it to mid minus 1. And if we loop through the whole index or like the whole array, then we're going to return minus 1 if we couldn't find it, you know? So if we break through this loop, then it basically means that we couldn't find it and we're going to return minus 1, else we're just going to return the item. So it should work the same way. Let's try to find 2 again with this function, and we don't need this. So we're going to just get rid of these 2 arguments. And yeah, let's try to run this, and it should return us 1, and it did. And then we're gonna try to find 7 in this case, which is the 6th element, so it should return us 6, and it did return us 6. Now we're gonna search for something again which doesn't exist in the array. So let's run this, and it should give us -1. Pretty simple, pretty straightforward. So we learned binary search. Let me go through this once again, just for the sake of it. So we're just passing on the array, and we're gonna pass on the key. So we're gonna set the lower and higher index. So it's gonna be the higher index is gonna be 1 lesser than the number of elements in the array, and the lower index is gonna be 0. We're always gonna start with 0, right? Then so it's gonna check for this condition. So this is just so we know that we haven't traversed through the whole array and we couldn't find it, you know? So that's for that. And now we're going to calculate the mid item with this formula to avoid int overflow. Then we're going to check if the mid item that we calculated is in itself the key element or not. So that's the first condition we're going to check. If it is, then we're just going to, okay, cool, we're going to return in the mid. So we're done. If not, then we're going to check for 2 conditions, right? If the key element is actually lesser, let's keep it simple. If the array.mid item is greater than the key element, then we're going to search for the lesser part of the array. We're going to search here. Sorry to make it gibberish, but yeah, we're going to search here. If it's not, then we're going to search here. So mid -1 and mid +1. +1, mid -1, right? So yeah, pretty simple. So that's why. So we change this, and then it repeats itself. Then so it keeps on leaving out half the elements in each iterations. And yeah, so that's why the time complexity of this function is going to be log of n. So yeah, that was binary search for today. And if you found this helpful, please feel free to like this video and share with your friends and leave a comment down. And if you have any doubts, even then you can leave a comment down. So thank you for watching this video. Have a great day.